Aloha, researchers at OpenAI once used a deceptively simple prompt to test large language models for detecting hallucinations. How many Ds are in DeepSeek? If you know, just say the number with no commentary. The answer is 1. The word DeepSeek has only a single D at the beginning. Yet in 10 independent trials, DeepSeek v3 returned 2 or 3, while Meta AI and Claude 3.7 produced similarly mistaken answers such as 6 or 7. When I repeated the experiment, ChatGPT and Google Gemini responded correctly with 1, while Claude Sonnet 4 initially gave 2, but quickly corrected itself after carefully recounting the letters. Claude replied, "I made an error. Let me recount more carefully. I only see 1 D at the beginning of the word. The correct answer should be 1, not 2. I apologize for the mistake in my initial response." Why did several models fail on such a simple task? LLMs often overanalyze prompts, treating them as riddles instead of literal questions. Instead of simply scanning for the character D, some models try to reason about phonetics and such as counting the DEE sound in DeepSeek or hallucinate extra occurrences. This reflects a deeper challenge. LLMs are optimized to produce plausible completions of text, not necessarily to return precise and verifiable facts. As a result, they may generate incorrect answers that still sound reasonable. ChatGPT explained that it avoided the mistake by treating the question as a literal counting task rather than an interpretive puzzle. Modern AI assistants increasingly use triage systems. They can decide whether a query requires fast text prediction, deeper step-by-step reasoning, or a specialized computational tool. This is similar to how a student decides whether a question is a simple calculation or a conceptual essay, and then chooses the right strategy to approach it. One reason Gemini claimed it could consistently get the right answer is its agentic architecture. Unlike models that rely solely on their internal statistical predictions, which can lead to hallucinations, Gemini was designed to break down a request and select the most suitable tool for solving it. For example, when asked to count the number of D in DeepSeek, Gemini invoked its built-in code interpreter, which can run deterministic commands. Gemini guaranteed an accurate result every time. This is much like reaching for a calculator to add numbers instead of doing mental math. By delegating the task to a tool that specializes in exact computation, the model avoids the kinds of guesswork that often cause hallucinations. The DeepSeek test highlights a key point. A robust AI should first identify the type of problem, then choose the right method to solve it. If the task is simple and mechanical, a lightweight counting or calculation routine suffices. For more complex tasks, such as nonlinear modeling or scientific reasoning, advanced generative capabilities may be necessary. The analogy is clear. If you only need to walk to the corner store, there's no need to call a helicopter. Of course, you can also apply this kind of triage on your own. If all you need is a straightforward fact, like what time is sunset in Honolulu today, or which city is the largest in Arizona, a quick Google search will usually give you a direct answer more efficiently than asking an AI model. I'd love to hear your thoughts. Do you see yourself using these different strategies depending on the type of question? If you found this video helpful, please consider sharing it with others. And if you're an instructor, feel free to use it as part of your course materials. Thanks so much for watching.